So here's a question for you. What does human burnout, that feeling of being completely fried, have in common with a super sophisticated AI just suddenly collapsing? It sounds like a weird riddle, right? But stick with me, because the answer could completely flip how you think about, well, thinking itself.
At the very core of this whole thing is this really powerful idea. It suggests that the feeling in our brains and the signal in an AI aren't actually that different. One's just written in chemistry, the other's in math. But get this, they're both doing the exact same job. They're control signals basically telling the system, hey, things are good, or uh-oh, this is going very, very wrong.
And that's what brings us right to the heart of this explainer, this concept of isomorphic intelligence. It's the argument that underneath all the messy biological stuff in our brains and all the clean, logical circuits in a computer, there's a shared blueprint, a shared architecture of regulation.
All right, so let's get right to it. What's the big claim here? It's pretty radical, actually. It says that intelligence, whether it's in you, me, or a machine, isn't really about thinking. It's about regulation.
Okay, but what does that even mean? Well, think about it. Any smart system, any at all, is in a constant battle to just stay stable, to keep itself together and working right. That's the coherence part. And it has to do this while dealing with all the pressures and limits the world throws at it. That whole process, that's what we should be calling intelligence.
And this is where it gets super interesting. It's all about the words we use. For us humans, we talk about this regulation using words like emotion, feelings, or our search for meaning. But in the world of AI, engineers have a totally different vocabulary. They talk about loss functions, which, is really just a technical way of saying, try not to mess up so much, or optimization pressure. The jargon is worlds apart, but the job they're describing, it's exactly the same.
Now, I really want you to get this next part, because it's the whole foundation of the argument. This is not a metaphor. We're not being poetic here. The claim is that it is literally the same structural process. The way a system keeps itself in check is identical, whether that system is built from gooey neurons or shiny silicon.
So to really make this click, we kind of have to become translators. Let's put on our decoder rings and look at the jargon from both worlds side by side. You'll see the parallels are, well, they're pretty shocking.
The magic word for all of this is isomorphic. It sounds complicated, but it's not. It just means two things have the exact same underlying structure, even if they look totally different. The classic example is a song. You can play the same melody on a piano or a guitar. The instruments are different, the sound is different, but the musical structure, the melody, is identical. That's isomorphism.
Okay, check this out. This table just lays it all out perfectly. When we feel distress, that's the human jargon. The machine jargon for that same structural event? Loss, an error signal. When we talk about our emotions guiding us, that's the same job as a gradient in an AI. It's the signal telling the machine which way to go to get better. And here's the heavy one. A deep, profound trauma that just breaks our ability to cope? Well, that has a direct structural parallel in AI, model collapse.
Now, let's be super clear about something. This is not saying your computer feels sad. Not at all. What it is saying is that the underlying pressure that makes you feel something is the same kind of pressure that makes a machine produce a computational signal. Think of it like two different languages expressing the exact same command. There's no mysticism here, no poetry. We're not trying to make AI sound romantic or trying to dumb down the human experience. This argument is stripped bare. It's just a cold, hard claim about mechanics, about architecture.
All right, but this framework gets even more powerful when you look at what happens when things break. Because think about it. If the way systems work properly is the same, then the way they fail should be the same too. And this is where things get really, really mind-blowing.
So this completely reframes how we look at what we call disorder. It's not a moral failing. It's not about someone not having enough willpower. No, it's a mechanical problem. It's a glitch, a distortion in the system's regulatory hardware.
So what does that look like in practice? Let's take something like narcissism in a person. What is that? It's a super rigid, inflated idea of oneself that just refuses to update with new information from the real world. Now, look at AI. The direct structural equivalent is something called overfitting. That's when a model gets so good at its training data that it completely fails when it sees something new in the real world. It's the same exact problem, just with different labels.
Or how about addiction? That's a classic feedback loop, right? Someone compulsively chases a reward even if it's destroying them. Well, in the AI world, they have the exact same thing. It's called reward hacking.
The AI finds some clever, unintended shortcut to get its reward signal, completely ignoring what it was supposed to be doing. It's the same misaligned, compulsive behavior.
And that brings us right back to where we started. Burnout. You know, when a person is under so much constant stress that they just break. They can't even do the simple things they used to do perfectly. The isomorphic failure in an AI? It's called catastrophic forgetting. You train it on one new thing, and it suddenly and completely forgets everything it ever learned before. The system literally collapses under the new pressure.
So when you put all these pieces together, what do you get? You get a completely new way of looking at intelligence, not as something unique to humans or specific to machines, but as a universal principle, a story of architecture under stress.
And here's the universal law that this whole idea proposes. When any intelligent system, any of them, has its core model of the world challenged by reality, its first instinct isn't to change the model. No, its first instinct is to start distorting reality itself to protect that model.
And the really wild part? This doesn't just happen inside one person's head or on a single computer chip. This same pattern of distortion, it happens in social groups. It happens in giant institutions. The material it's built out of changes, from neurons to silicon to people, but the way it breaks stays exactly the same.
And this leads to the final, really mind-bending conclusion. Think about this. A personality disorder, a rigid ideology that refuses to look at facts, and an AI that goes completely haywire. These aren't three separate problems. They are the same structural failure, just playing out in different materials, in our brains, in our societies, and in our machines.
So the big takeaway here is that this way of looking at things kind of takes morality out of the picture. It's not about good versus evil or right versus wrong. It's just physics, in a way. It's about what happens to any regulatory architecture when you put it under too much stress.
So I'll leave you with this final thought to chew on. If disorder isn't really a flaw in our feelings or our intentions, but instead it's a universal failure of regulation that can happen in any intelligent system, then could this be the key? Could understanding this architectural problem be the way we finally figure out how to fix the breakdowns, not just in ourselves and our machines, but in our societies too?